Well, yeah, thank you very much for this kind introduction. So exactly, this talk is called Preconnect, Prefetch, Preload, and Prewat, an introduction to resource hints. And I would like to talk about why web performance matters at all in the first place. So why are we even thinking about improving website speeds? Then I would like to explore why some websites load slowly, and then go into resource hints and how you can use them to make your websites load much faster than they might do currently. So why should we care about web performance at all? The simple answer is because it has shown to have a significant effect on business results. So large companies ran a lot of studies that showed exactly this. So I want to show two of them. Amazon allegedly once ran a study where they deliberately slowed their websites down by only 100 milliseconds, and they already saw a drop in sales by 1%, which is obviously kind of significant when you're operating on a scale as Amazon does. And the second one is from another large US-based company that's called Google, and they found out that 53% of users will abandon a website if it takes longer than 3 seconds to load. I'm apparently a bit more patient because I often wait a bit longer, but this is what they have found out. But I think it's even more about something more important than business. It's also about empathy, because especially with those that have to endure poorer network conditions than we have. And I think we ought not to take anybody's time as granted, and we should not be wasting it if we can do better. And I think we as web developers are the ones that are in the position and maybe even responsible to deliver fast websites. I would like now to go to why websites load slowly. And in order to do that, we need to know at first or talk about what actually is a website. So usually a website is a small text document that contains references to other small documents such as scripts or images or CSS files that also need to be downloaded in order for the website to be useful at all. And this is kind of different to, for example, if you download one large binary file, for example, if you download a video. And in order to download a website, you actually have to send data, right? And if you think about it, that data it doesn't get beamed, it has to travel. And I would like to give an example where I'm in Germany and I will request a website in New York. So, and if I do this, then there's, the distance is roughly 6,100 kilometers from Hamburg to New York, and then also 6,130 kilometers back because I also need to get an answer, right? So, and how fast can data travel? So there's this thing that is called the speed of light, and until now we weren't able to do anything that is faster than that. So, and this is around about 300 million meters per second. But in reality, data in fiber cables travels in more like 200 million meters per second. This means for one data package to go to New York and coming back to Hamburg, it already takes 62 milliseconds. And this is for only one single data package. And I would now like to have a look on what happens on the network when we are requesting a website or when we are connecting to a server. So what do we have to do and how many round trips this causes? So the first thing we have to do is we have to kind of find out where we can or how we can connect to the server. And in order to do so, we need to ask a domain name server for its IP address. So in this case, I will just ask the DNS server, hey, DNS server, I would like to go to some domain. In this case, it's devfest.de. And then the DNS server will resolve that for me and give me the IP address back. And this already has taken 62 milliseconds. And then, because HTTP uses TCP as its transportation layer, we also have to open a TCP connection. So, and in order to do that, we send a package, and then we get a synchronization and acknowledgement package back, which also adds another 2 round trips to open the connection, where we are now already at 124 milliseconds. But now we are in the year 2018, and most websites are delivered securely, which means we also have to do a TLS or SSL handshake, which in itself adds another 2 round trips because we have to kind of exchange information about which cipher suits are supported, and then we need to exchange the keys and also the certificate, and then in the end we can send the encrypted messages. And like I said, this also adds another 2 round trips, and now we're already at 248 milliseconds under best case conditions, right? So we didn't even account for the DNS server having to calculate the response or any routers that take up some time. And this is a quarter of a second already. And we also neglected one major thing, that most or a lot of current network traffic goes over mobile networks, which by their sheer nature always add a fixed amount of latency to each data that is, to each package that is going to be sent. So for example, for LTE, this is rather small, it's only 70 milliseconds, but if you are on 3G, which is pretty common in most countries, this is already between 150 milliseconds or 400 milliseconds, and on 2G you are basically lost because it's almost 1 second for each request. And if you do the math, then you kind of end up for a normal 3G connection to open a connection to a web server. It's already 1,000 milliseconds, so 1 second before any data is sent at all. And when I researched this, I was kind of the impression that cannot be true because it just seems way too much. But then I ran a test on a service that is called webpagetest.org. So if you don't know it yet, then please look it up. It's super awesome if you want to just see how your website is performing. It has a lot of more features than only this waterfall chart. But this is the waterfall chart. In this case, I requested USA.gov from a server in Frankfurt, I think, under 3G conditions. And I covered the download part, so with this icon. So what you can see there is only what it takes to connect to the website. So it's DNS, TCP, and TLS, and it's already 1.4 or 1.3 seconds. So it's actually true. So now that we opened the connection, we can happily start sending data in full speed, right? Well, of course not. It doesn't work because TCP has a bunch of algorithms in place that protect the network from collapsing, because you cannot just send data if your recipient is not able to handle the data, then you would just congest the entire network and it would break down. So, and one algorithm is called TCP slow start, and it works in a way that when you start sending data, it only does it slowly, so you have to send one package and then you have to wait to get one back before you can send even more data. And this slowly increases until you at some point reach maximum speed. And usually this amount of data is 14 kilobytes, so if you happen to manage to get your entire website into those 14 kilobytes, then you have only one additional round trip, which would be awesome, but I don't know if anybody is capable of doing that nowadays. So yeah, and the thing is that when you're using HTTP1 and not HTTP2, then you have this TCP slow start punishment, so to speak, for each connection that you are having. So if you are downloading images, 5 images from the same host, then you are opening 5 connections and you have to endure TCP slow start for each of those connections. And this leads to the following conclusion, that usually latency and not bandwidth causes slow websites, because in this example, it didn't matter much if I have 100 Mbit connection or 50 Mbit or 10 or 1 gigabit, because we didn't send large data yet. And engineers over the years came up with a lot of techniques to mitigate those issues and to decrease latency. So first of all, there is now HTTP2 multiplexing, which allows you to reuse open TCP connections. So when you are downloading 5 images from the same host, then only one connection will be used. So you can probably download the 3rd, 4th, and 5th image on a full speed, and you are not subject to TCP slow start 5 times, but only once. And then there's content delivery networks, which basically try to move their servers closer to the user's location and literally decreasing the distance data has to travel, and therefore reducing latency. And the third one is caching. And with caching, you can kind of remove or bring the latency down to almost 0, because once the file is in the cache, it will be just delivered from either the disk or the memory. The issue with that is that it only works for the second request, because in order to be able to serve it from the cache, you somehow need to put it there, and that usually happens only when you see it, when you download it. So, and this is where resource hints come into play. So resource hints are kind of a way of predictive caching. It gives you the ability to point the browser to resources such as scripts, CSS files, documents, images, whatever you can think about, before the browser can even know that it's going to need them, either for the same request or for a request that might be the next one or even 2 requests away. And the best, or one cool thing about it, that implementation is also rather simple, because usually you can just inject a link tag into your head and get going. And I would now like to go through all of them basically and show what they can do for you and how you can use them, and give some examples how you can use them. And I would like to start with preconnect, because preconnect does all the things that I just mentioned. It resolves the DNS, it performs the TCP handshake, and also does the TLS setup. And I would like to give one concrete example for that. And this is web fonts. So who has web fonts on their website or worked on a website with web fonts? Okay, yeah. That's most of them. So I also created a website. I have this cat shop. And I have an issue. So I need this web font because the website needs to be cute, so I can give most the kiddies a new home. But I also need it to be loading fast, because otherwise my conversion will drop, and I don't want that. So this is how my head looks like currently, and I have the style sheet, my personal style sheet, but I also have the Google Web Fonts style sheet. And maybe most of you already know, but I'm going to mention it anyway. Google is offering a rather popular web service where you can download web fonts from, which is called Google Web Fonts. And here's the web font style sheet. So my style sheet is rather simple. It only contains the font family IndieFlow, which is the web font that I'm going to download, and of course also the color fuchsia, because CI and branding. And this is the Google web font style sheet, and it's important to know that this is not the web font file itself. It's only the style sheet that references the actual web font. And you can see here it's for the name IndieFlow, and then there's the URL that points to the web font file. I will come to that in a second. When I now open my website, this is how the waterfall chart looks like. And can you even see that? Okay, awesome. And so at first my website is downloaded, so I added some annotations. So first DNS, and then TCP, TLS, and then you see the actual request happening. And once my website is downloaded, the browser sees that I have embedded my style sheet and also the Google Web Font style sheet. And then it will download both of them in parallel. And as you can see here, like at the bottom, only after both have been downloaded, it will download the web font itself. And why is that the case? So browsers usually tend to download as little data as possible to not waste any bandwidth. So they are only downloading, for example, background images or web fonts when they are actually used on the page. And in order to know if they are used on the page, they have to download all the style sheets and then also the HTML, and then apply the style sheets and check the selectors and see if those selectors match, and then download the images and web fonts or not. And this is why they have to download both, and only then will download the actual web font. And as you can, or might be able to see, it takes roughly 4.2 seconds to download the entire page under 3G conditions. So there's one important thing about the Google Web Font API, that is that the path is not stable. So if you were just to preload the entire font, then it wouldn't work, because it might change tomorrow or in a week, you cannot know. But what has been relatively stable throughout the years is that it is going to be served from a host that is called fonts.gstatic.com. So that hasn't changed in years, or I don't know if it has changed at all, ever. So what you can do is you can add a link tag to your head with the rel set to preconnect. So and the href set to where the web fonts are going to be downloaded from. And this will advise the browser to, or force the browser basically, to already connect against this host, so doing DNS, TCP handshake, and TLS handshake. And then there's also a cross-origin attribute, which we ignore for now, and I will come to this in a second as well, because it's kind of interesting. But if we add this to our head, then the resulting waterfall suddenly looks like this. So again, my website is downloaded, and then it downloads both style sheets parallel as before, but now it already connects to the host of the web font. It doesn't download it yet, so you might notice the gap because it still needs to evaluate both CSS files in order to know if it's actually going to be needed. But we already told the browser that we want to connect against this host, which it does right away, so that when the web font file needs to be downloaded, it will be much, much faster because you don't have to open the connection because it's already been opened. And now it's only 3 seconds or 3.1 seconds, so we got rid of more than a second of page load time by only adding this link tag to the head, which I think is kind of amazing. Quickly going back to this cross-origin attribute. So I guess for DRM reasons, web fonts are subject to the same origin policy, so that you cannot just include web fonts from anybody. And the font face specification requires that fonts are loaded in anonymous course mode. And for some reason, I don't know, maybe some of you can answer this, is browsers appear to maintain a separate pool of TCP connections for those kind of requests, which means if you do not set cross-origin, then you will have 2 TCP connections because it cannot reuse the first one. So let's have a look at the browser support. So the browser support is actually pretty good. It's supported for 70% of users apparently already. So I think it's safe to already just use it. The second resource hint is called DNS prefetch, and it is kind of similar to how preconnect works, but it only does the DNS resolving and does not open the TCP connection. And this is mostly useful for resources that you will not need now, but now-ish, where you don't know if it's going to happen in a second or maybe in 5 seconds or maybe even in a minute. And one example I would like to give is Amazon. So Amazon has this autocomplete feature, which you might have already seen. And this is really quick. And the thing is, the autocomplete service itself does not live on Amazon.com. It actually lives on completion.amazon.com, which is a different host than Amazon.com. So if you were to start typing, your browser would need to resolve this host before it can actually make the request. And what they are doing is, in their head, they add this link tag with the relation set to DNS prefetch and the href set to completion.amazon.com. So as soon as you open their main page, this is already going to be resolved, and when you start typing, it will just appear and work, which is cool and also simple. And it has even better browser support than preconnect, which is kind of interesting. So what you can do is, if you actually want preconnect, but also want to give browsers that do not support preconnect, but do support DNS prefetch at least something, the DNS prefetch, you can basically just specify both in one link tag. And then if the browser supports preconnect, it will simply use preconnect. And if it does not, but does support DNS prefetch, then it will resort to DNS prefetch. The next one is prefetch. And prefetch allows you to actually download resources, but that you don't need right now, but that you are going to need later, and like for future navigations. So, and cache would apply. So if you prefetch a file and it has a cache lifetime of 1 hour, then if you come back later, then it will still be served from the cache. The thing to know is that prefetch files will not be executed. So it's totally safe to prefetch, for example, scripts or images. They will just be downloaded and with a low priority, and nothing will be done with it until you need it. And I would like to give two examples for that as well. So going back to my cat store maybe. So usually an online store flow is pretty clear. So I have a product page, and then I put products into my cart, and then I go to the cart page. And then from the cart page, I go to the checkout, which sometimes is a separate checkout, a separate application. And then I will give you my money there, basically. So what you can do when I'm on the cart page, you can be pretty certain that I'm going to go to the checkout as well, because if I'm already in the cart, why wouldn't I? So you can, at this point, already prefetch the files that your app is going to need for the checkout experience, and then just prefetch them. And as soon as I hit this go to or proceed to checkout button, the stuff will already be there, and leading to a better experience. The second example is similar, but maybe a bit different. So if you have a login page, a login form, then you can also be pretty certain that my intent is to log in and use the logged in experience. So why not just prefetch the assets, like images and scripts that you need for the logged in experience at this point already? Because it doesn't hurt if you are pretty sure that I will need them, then you can use the bandwidth and just give me a better experience. And the browser support also is pretty good. All of this got a lot better in recent months because, okay, in this case not, but also Safari and iOS Safari started supporting ResourceHints apart from this one apparently. So this is pretty good. And this is even supported in IE and Edge, so pretty safe to use. The last one I would like to talk about is also the newest one and maybe even the most interesting one. It is called Preload. And you can use Preload to download resources that you need for the current navigation, for the current page view, but that the browser cannot know about yet, but you do know. So now I would like to go back to my web font example, and just briefly go back to the initial waterfall chart, like the first one, like just to recap that we had to download both CSS files and only afterwards the web font was downloaded. And I know I earlier said that when we're using Google Web Fonts, we cannot know the path, but let's just pretend for this example that we can know the path. And if you actually wanted to use this technique, you could also consider hosting the web font yourself and be in control of the URL and then know it for sure. And, oh, I got one too fast, sorry. So what you can do is add this link tag with preload and then set it to the href that we now pretend that we know. And what happens then is, if you look at the resulting waterfall chart, that the web font itself will be downloaded in parallel with all the other stuff and will be ready much earlier, which is kind of cool. And you can use it for all kinds of stuff, and we will come to that right now, because if you might have noticed, there was this as attribute in here. And the as attribute is the request type. And you can have plenty of them. You can use scripts, for example, if you have third-party scripts that you are loading by an inline script loader, or you can have images that maybe are referenced as background images in your CSS files. And you can even preload fetch requests, which gives us interesting new stuff, which I don't want to get into detail right now. But why do we even have to set request type? Why do we need it? So it's needed so that the browser can prioritize the request, because style sheets might be downloaded with a higher priority than images, but it is also used to set the appropriate accept header so that the browser doesn't request an image when you actually want a script from your web server, so that you can deliver the right thing. But it's also used to enforce the content security policy. And if you were in the first talk this morning, you might already know what it is about. But content security basically allows you, in this case, to specify from which host you want to allow to download resources from. For example, you could say, I only want to allow images to be downloaded from imageserver.com, whereas scripts should be downloaded from scriptserver.com. And in order to enforce that, the browser needs to know with what kind of file type it is dealing with. And if you fail to set a resource type or set an incorrect one, then you will basically have double fetches, and preload will not give you anything. One other thing is there's responsive design. So which is basically trying to make your web app work across screen sizes, right? And oftentimes you need to download resources depending on the screen size. For example, a background image for mobile version might be a completely different one than the one for the desktop experience. And usually people use media queries for that. So you specify a max width, and then if the max width of your device is in this realm, then it will download this, and otherwise the other. Luckily, browser vendors had this also in mind when they invented preload. So you can use the media attribute and preload and the link tag as well, and then set max, for example, max width. And then the browser will only download or preload those where the media query actually matches. And preload is the one resource hint where support got significantly better in the last 3 months even, I think. So it's now supported in all major browsers but IE. And it's even already in Edge 17 apparently. So I think it's now ready to be used. And I would definitely look into that. So, and with that, I'm almost finished. But I would like to finish this talk with 2 book recommendations. So if you're interested in this topic, I can highly advise the book High Performance Browser Networking by Ilya Grigorek. This one is even available for free as a progressive web app on the internet. So feel free to Google it and read it, maybe on your way home. And then there's also, and in fact, basically the first 5 to 10 minutes in this talk were out of this book. So, and then there's also HTTP, the Definite Guide, which I also enjoyed reading a couple of years ago. So, and with that, I would like to thank you for listening and see you around.
Thank you, Robin.